Oh, we're up. We're live. Okay. We're on. Hey, everybody, and welcome to PerfWeb 24. Thank you all for joining us. Appreciate it. This is our parts 3 and parts 4 of Concepts in ECMO. And my presentation today is going to be on ECMO circuit design, followed by Matt Warhoover talking about the different tools for delivering ECMO therapy, and then also he's going to be talking about an ECMO staffing model, and Matt's going to be coming in via Skype from Vanderbilt, and I'll introduce him formally at that time. In case you're just now joining us, let me introduce you to our panelist for this evening. Sitting next to me is, not standing, but sitting next to me is Tammy Lee Sparacino. She graduated from the Texas Heart School of Perfusion in 2003, currently works as a perfusionist with Houston Extracorporeal Technologies here in Houston. And then next to her is Kara Armstrong, BSN RN, and she is a perioperative services educator at a local medical facility here in the Houston area. Kara's been on our program before, so welcome back, Kara. And Tammy, this is her first time. We just finished with the extra program on fire in the OR, and that was quite, I think, an interesting thing. This is going to be more, I think, geared towards what I'm used to anyway. That was kind of an added thing, and it was fun. So what did you think of it so far? You liked it so far?
It was great. It's great being here.
And Kara, always good to see you. So I wish all of you could join us for tomorrow, because tomorrow, part 4 of our Concepts in ECMO, we have a crawfish boil afterwards. So if you're in the local area and want to attend, call in. If you call in, you can do that. Okay, so I have to go through these various things that my list right here. So we have all kinds of social media. We have YouTube, we have the Facebook, and we have the Twitter, okay? So we need you to subscribe to the YouTube, okay, please. Make sure you like and share. This is very important. And you know what? Before you go any further, let me tell you, we have 718 subscribers on the YouTube. We need to be at 1,000. So please, 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 please subscribe. We really need you to subscribe and click that notifications button so you know when we're live. Now, you need to like and share us on the Facebook, and you need to make sure that you follow us and share us on the Twitter, okay? So, and then the YouTube chat, if you're watching via YouTube, because I can only monitor one. Somebody else is kind of watching the Facebook, but it's hard for me to monitor all of them. I have my computer here for the YouTube chat, but you can chat your questions there, or better yet, it's better to call. And when you see this symbol here, the call-in number, please feel free to call. The telephone is right here. You'll be live on the air, and you can ask your questions. It's very simple to do. And really, it's easier. We really enjoy it if you do that. If you call in with a really good question, tell us who you are, please, where you're from, all that kind of stuff, you get one of these cups for calling in with your question. So, you really want one of these cups, okay? I want these cups in every household, all right? This is my Green New Deal. It's going to be the Green New Deal. Everyone gets a cup, okay? Green New Deal? Green New Deal? Oh, no, I'm not going to say that. Okay. Our technical guys are suggesting I say something, but I'm not going to say it. I'm going to, for once, zip it. Okay, that's very unusual for me.
That is very unusual.
Okay, so with that said, I'm going to go ahead and get started on my presentation and then bring in Matt, and then we'll have a lively discussion. We'll have a talk, I think a break, and then a talk, his talk, a break, and then his talk, and then a discussion, okay? So if y'all are ready, let's go ahead and throw my slides up, and I'll go ahead and get started. Okay, so thank you very much. Okay, so ECMO circuit design and safety. So here's the nurse. She is getting ready for her shift, and when she gets to the hospital, she finds out that she is going to be managing the patient on ECMO. And she's really changed quite a bit since then, because the question really is, what can go wrong? Well, a whole number of things can go wrong, all right? You have, for example, this scene. Now this looks like an operating room, and it is. It's an operating room, and it looks like it was a kind of a bloody surgery, but bear with me here just for a second. And here's a picture, still operating room. There's somebody with their hand there kind of pointing. I'm not sure if they're going, look at this mess. I'm really not sure what they're saying, but you can see it's a pretty bloody scene. There's the blood on the floor again. And it even made its way over here to this cart because it sprayed around everywhere. So it's the issue that happened was a line on the positive side, fortunately, of the ECMO circuit that was a sampling line came apart. And when it came apart, as you could imagine, the blood shot everywhere because it's under tremendous pressure. And that's what it looks like. So there are a lot of things that can go wrong. And building a circuit that minimizes those things is a really good way to go with this. I'm going to talk a lot about simplification, but also how simplification may not necessarily afford you the degree of utility that you might need. So let's talk about this moving forward. My next slide. Here's another example of what can go wrong. All right, so you're sitting there and it's in the middle of the night and everything is going well and you see this. Well, that's not necessarily good. And what that is plasma leaking out of the oxygenator. And the reason this happens is for a variety of reasons, but predominantly if you use a polypropylene fiber oxygenator, which is what this happens to be, then it will react with lipids. And when it does, it changes from being a naturally hydrophilic to hydrophobic to hydrophilic, swells, and the pores of the fiber get larger and allow for plasma to leak out. The only way to solve this problem, one, is to keep it from happening, which is to not use propofol, which is a lipid-based material. And the other option that you have is, of course, if the patient's hyperlipidemic, it could still be a problem. And it's not always going to occur, but it does occur more frequently. But if you use a polymethylpentene or PMP fiber oxygenator, like would be the Levanova EOS or the Quadrox, the Maquet Quadrox, or because they're called Getinge now or something like that, those are made of those fibers. Now, important to note, both of these oxygenators, the one you're seeing here, which will usually last 5 to 7 days. So if you have a patient that you put on ECMO, you are anticipating a 2 or 3 day run, it's a lot more affordable, and it's a great oxygenator, works just fine. But if you're expecting a 30-day run, even though I don't really think that PMP fibers last 30 days all the time, they may last a little longer, but they don't last forever. So I think there's some debate about what is the right way to do it. But if you do want to use propofol, you really almost have to be committed to using the PMP fiber and not using the polypropylene fiber-based oxygenators. But this oxygenator has to be changed. And it's not necessarily a dire emergency, but it's certainly something that you have to do. So as you can see here, ECMO utilization, the number of ECMO centers has grown astronomically over the past 6 to 10 years. And it's anticipated that it will continue to grow, and the use of ECMO is going to continue to grow as time goes on. And you can see here a variety of pictures. These are all from Paris, France. And these are ECMOs that have been placed in the subway, in the top right corner, in the bottom left corner, it's in the Louvre. In the middle picture on the bottom, it's just on a street. And on the bottom right, it's in a grocery store. And I don't know if you can see it or not, but I don't have a mouse. But if you see that lady in the back, she's just looking for the milk right now on the expiration date. But nevertheless, it's quite dramatic. And this is a pilot project of seeing if they can put patients on ECMO in the field and then transport them to the ICU. So a specially trained team with a cannulator will go out with the ambulance, resuscitate the patient, put them on ECPR, and then bring them to the hospital or to the ECMO center, as the case may be, that is waiting to receive that patient. And they have seen, and I don't remember the numbers exactly, so I don't want to misquote it. Matt, hopefully when he comes on, we'll ask him, because he knows those numbers. But they have seen remarkable improvement in survival rates by getting circulation established out in the field before transporting to the emergency department of the hospital. That time frame makes a difference. And look, this may not be for the the 80-year-old grandma that went out while she was tending her garden, but for the 38 or 40-year-old who is at the grocery store with his wife, or at an art exhibit at the museum with his or her wife or husband, as the case may be, who should not be dying. This is perhaps life, and I think this is going to increase ECMO usage in these circumstances. Right now it's predominantly used for VV, but I think that VV will continue to grow for pulmonary failure. But I think that the rescue therapy, ECPR, is seeing a resurgence because we've gotten much better at it. So ECMO usage is going to go up. And Matt's going to be talking about staffing models, but as ECMO continues to grow, it's making a real challenge for us as perfusionists, in that we can't manage all of these. There's simply not enough of us. And Kara, this is where nursing is going to be making a big difference. They're going to have to get involved in this. We cannot, I'm telling you, we are looking at a potential crisis if we do not start figuring out now what to do. I really believe that. So this is basically your basic ECMO. And can I have a mouse so I can point with it by any chance, if you have one? Pointer? They don't have, they wouldn't see the pointer. I have to have a mouse so that they can see it on the web. Here, hold on, I'm getting a mouse. Yes, oh, that's helpful, thank you. Do you have the pad? No, that's okay, they can see you, thank you. Is it on? Yeah. Okay, so there. Oh yeah, there you go. Okay, so this is basically an ECMO platform that you see here on the right. And this is actually an EOS oxygenator. You see it's blue versus yellow, so this has the PMP fiber in it as well. And you see the loop right there, and the centrifugal head that would be the essentially the heart pump, or what ends up is the propulsion unit for the blood through the circuit, okay? So, but this is a basic platform. There's multiple platforms out here. I'll show you some of the other ones. We're not here to advocate necessarily any one platform, but I do have a lot of experience with this one, and it's a very nice system. It's easy to move around. It's not going to go into a helicopter, but it will go on an ambulance. And we have transported I've transported a number of patients with this platform on an ambulance, and it works just fine. So this is a basic ECMO system and a diagram of it. And this is, oh, I didn't mean to do that. Take that away. I put this on here to show you the most simplified version that I can show you. You have this says femoral vein, but it could be jugular, whatever. But you have access, and it's coming down into the pump, out of the pump to the oxygenator and heat exchanger unit, usually combined. And then it goes out and back around and back into the patient. So your only two connecting points are here and here. And if you have those on securely, then all of these other ones can actually be pre-assembled by the manufacturer and solvent bonded, so that these cannot be removed. Your only points of risk for anything disconnecting are these two sites. And I'll show you a video at the end where that can be secured by putting it on firmly, making sure it's past the third barb, using tie bands, doing whatever you can do, or cable ties, they call them, in order to make sure that it's secure. But it's certainly the safest. But this has it has good utility for its purpose. But if you need to draw a circuit gas, where are you going to draw it from? If your patient is needing, very, very rapid, massive fluid resuscitation or blood resuscitation, where are you going to give it? How do you draw an access gas either pre-oxygenator or post-oxygenator? If you really wanted to see what your oxygenator was doing. Now you could have inline, I guess, continuous monitoring that is already in place from the manufacturer. But again, all of these things start to add up. Cost starts to go up. What's their shelf life if they're already attached? How can it? Because usually they're in a cellophane pack, and you really have a hard time. Your shelf life is going to go down dramatically, and of course, those are all going to be issues. So. And if you wanted to do CRRT on the patient, as you see here, this patient is getting both. Here you have your access is coming from the positive side, which is then going down through a stopcock. Some of it's going to the CRRT and coming back up, and usually the stopcocks are down here. There's usually a pigtail. You almost never want to put a stopcock directly on the connector itself because there's a risk of it being broken off. And if you remember my previous slides, when it does get broken off, it can be rather dramatic and very difficult to control. Not to mention, you have to change it because you have to interrupt all of the support that you're giving the patient. So you're in a very compressed time frame. It is a very big emergency. It's a big, big problem. But if it happened on the negative side, it's much, much worse. The positive side's bad. The negative side's worse. And you've got all this blood squirting out. So what's the natural instinct for somebody? Put your finger over the hole. So now, is it a sterile glove that is it a sterile finger you just did that with? No. It's really bad. So protecting your circuit is critical when you think about designing a circuit. But you also have to think about, what am I going to do with this thing? Am I going to run CRRT through it? Or if I don't have any access or any return, I'm going to have to stick the patient again. If I have to stick the patient again, that might end up with a situation where I've created a bleeding problem on an already bleeding patient because they missed the stick and they hit the artery versus the vein, or who knows what else is going to happen. None of this is easy, and none of this is ever going to be perfect. So something to consider is, what are you going to be doing with your circuit? So ELSO guidelines for training and continuing education of ECMO specialists, their introduction says, the term ECMO specialist is defined for the purpose of these guidelines as the technical specialist trained to manage the ECMO system and the clinical needs of the patient on ECMO under the direction and supervision of a licensed ECMO-trained physician. The individual functioning as the ECMO specialist should have a strong critical care background in neonatal, pediatric, and/or adult critical care and have attained one of the following. And this is the part that I thought was pretty interesting. Successful completion of an approved school of nursing and achievement of a passing score on the state written exam by the Board of Nursing for that state. Now, I think that's good, but I think they should add to that a minimum of 2 years critical care experience, kind of like if you're going to go to the CRNA school. How do you take somebody who has 0 ICU experience, throw them in an ICU because they graduated from nursing school and worked on the floor for a year? I don't think that's wise. I think that should be revised. Successful completion of an accredited school of respiratory therapy and have successfully completed the registry examination, so that makes him an RRT, and be recognized as an RRT by the National Board of Respiratory Care. Now, we can stop and talk about this one for a little while. And that is, hey, can you bring these guys in on this when I discuss this? There you go, thanks. I like respiratory therapists. In fact, Chris Lusby, he's going to be here tomorrow. He used to be a respiratory therapist before he went to perfusion school. I'm not sure that I agree with this. I'm not sure respiratory therapists, they are in the ICU, they're with the ventilator, but do they understand as well the entire
Whole
patient.
picture.
Yeah.
The pressors, the inotropes, the bleeding, all the labs. They know the gases, but do they know the lights, the metabolites, the other biomarkers? Do they really understand that like a nurse does? I mean, perfusion gets it because that's what we do. But nursing gets it because that's what they do. In fact, they're better at most of that stuff than I am. But is a respiratory therapist really, truly equipped to be an ECMO specialist and manage some of the patients that I know you've had to manage? It's a debate that's going to go on forever, but what's your opinion?
Well, I think they definitely have a larger learning curve, and their training, really, they should probably have additional training on that type of thing. Whether it's, they have to, if they want to be an ECMO specialist, maybe they have to shadow an ICU nurse for a particular amount of time. Shadowing perfusionists for a particular amount of time. I don't know what the answer is, but I do think that they're going to have a great understanding of the ventilator. It's definitely better than I do.
Yes,
I mean,
agreed,
absolutely.
agreed.
They're going to be experts in that
Agreed.
area. And it really will depend on the particular respiratory therapist whether or not they have any knowledge of this other stuff.
That's true. I think it's just we're gonna wait and see. Okay, let me go ahead and do the slides again. So that's that. Number 3, successful completion of an accredited school of perfusion. Okay, that's us, and certified through the ABCP. Okay, well, that's fairly common. Physician trained in ECMO who have successfully completed institutional training requirements for the clinical specialist. And number 5, now this is the one that I thought was interesting. So other medical personnel such as biomedical engineers or technicians who receive specific ECMO training and have practiced as an ECMO specialist since the initiation of their programs, so they're grandfathered in, and who have completed equivalent training in ECMO management as the other specialists, have successfully documented necessary skills as an ECMO specialist, and who have been approved specifically as an ECMO specialist by the medical director. These personnel can be approved institutionally as an ECMO specialist under the grandfather principle. However, ELSO does not encourage or support the new training of individuals except as outlined in 1 through 4, as it says above, but previously.
Wow.
That's what I think. Wow. Now, this is either now, they say they don't support it or encourage it. They don't say it can't happen.
Well, they're allowing it with that particular
Yes.
item.
Yes. And this is either because they feel that we're going to be that short, or they don't want to exclude someone who's been doing it for a period of time. But is that really, again, concerns me. I don't think it's right. I'll just leave it at that. Okay, so here you see some costs. And I think these are interesting. This is an interesting table. The console and motor for the Centrimag is $43,360. The blood pump is $12,000. The tubing pack with the Quadrox deoxygenator is $2,000. So the total cost per circuit each time you use a Centrimag is $14,000. Actually, I've heard it was $25,000 now. I don't know when this. I don't know. That says 2014,
Yeah.
but I've heard this from our DA Palonzo in artificial organs. But that's what it is. The Rotoflow, which is just a centrifugal pump, okay, is $24.47 per circuit. The Rotoflow with the ICU package is the same price. And the Cardiohelp, which we're all familiar with, every time you use it is $13,781 per disposable pack. So that for the thing in the red, these are all the cost of the disposables. This is the cost of the hardware. So the hardware is part of the heart-lung machine, but on the Rotoflow, it's $42,000 just for the centrifugal pump. But this is what it costs you for the disposables, single use per patient. So when you have to change a Cardiohelp out, they're pretty expensive. Now, great device for transport on a helicopter,
Sure.
but not necessarily the necessary platform if you're going to be taking care of patients in an ICU, and anyone that is transferred, the transfer center is coming to get them with their own transport device, I think. Okay. And out of this, which in the same article, if you look here, who can watch it? Who should watch it? Well, perfusionists, Centrimag, Rotoflow, no problem, and Cardiohelp. ECMO specialists, yep, on the Centrimag. No on the Rotoflow. Yes on the Rotoflow with the ICU package. And yes on the Cardiohelp. The nurse at the bedside, in other words, they're taking care of the patient and the ECMO simultaneously. So it's one-to-one, not someone specifically managing the ECMO circuit only, but the patient and the ECMO. Yes on the Centrimag, no on the Rotoflow, no on the Rotoflow with the ICU package, and yes on the Cardiohelp. So why is this? Well, I think the reason for this is safety, and I'll explain why I feel that way. Well, we have controlled and we have catastrophic events. So in the controlled section, the oxygenator's failing. The clot, and failing meaning it's, you're going up on your sweep, your FiO2's at 100%, it's, giving you a PO2 instead of 400 or 300 coming out of it, it's now 140. It's PCO2s are 50, 60, no matter what you do. It's not an emergency. It's going to need to be changed, but it's a controlled circumstance. You start seeing clots starting to form. If you're measuring pressures, your premembrane pressure might be going up a little bit. Things are kind of looking icky, and it may be time to start changing this oxygenator out, so we're going to go ahead and do that. And then, of course, fiber degradation, which I showed you with the previous slide, where you start seeing a plasma leakage. It usually starts slow, and then it gets worse and worse and worse as time goes on. These are all very easy to manage if you're the nurse at the bedside who is managing the patient and the ECMO simultaneously. You can basically call somebody, they can come in, they're going to be on call, and they can help you deal with this situation. But when you get into catastrophic events, it becomes a different situation. Acute decannulation does occur, and when it does, it is catastrophic. There's nothing anyone except for the surgeon or physician who is capable of cannulating the patient to get that patient recannulated. Nobody can help. There's nothing anyone can do. And even then, even with the surgeon standing right there, an acute decannulation is usually a fatal event. O2 source disconnected and not recognized. That's usually a catastrophic event. Everybody's wondering, why is the patient doing poorly? And there's a reason, and it's the O2 line has become disconnected, or the source has been damaged in some way. Pump head or oxygenator, complete thrombosis, just completely clotted off. Well, if that happens, you're not going to be able to fix that. Line, or especially if the patient's ECMO dependent. If the patient's ECMO dependent, there's just nothing you can do. You turn it off to change it, you're not going to be able to get another one set up, primed, and ready to go. Even if you're trying to resuscitate the patient, which you would have to start CPR and hope for the best. But if they have no lungs, then what are you going to do? If they're on ECMO, and they're on not just for eCPR, but they're on it for both cardiac failure and pulmonary failure, you're toast. Line or access port disconnection. Those are not. It's not always catastrophic on the positive side. If it's just you turn the stopcock the wrong way and you get sprayed with blood and you turn it back the other way, you can get away with it. But if you do it on the negative side and you turn the stopcock the wrong way, and that negative pressure is, what do you think about? Negative 100, 120 on an ECMO if you're flowing 5-6 liters a minute?
Yeah.
Something like that. That's going to suck air into that access line, into the pump head, and then up to the outlet of the pump head, and it's just going to stop. And you have nowhere to de-air it too,
Release it,
because
right.
it's ECMO, it's a closed loop system. So it's going to be a battle to get that back on. And if the nurse at the bedside is managing that and taking care of the patient, and that's the reason why, going back to that previous slide, that you have what can be watched by the bedside nurse. The reason the Rotoflow and the Quadrox allow for that is their systems, and I'll show it to you, their systems are designed
Centrimag.
with Centrimag, that's what I meant, Centrimag,
Centrimag.
thank you. Their systems are designed with no access.
Right.
And no access in any of the lines. It connects from the patient to the patient, and that's it. There's nowhere to draw a lab. There's nowhere to do anything with it. You can't turn a stopcock the wrong way and create that scenario. But you can't transfuse through it. You can't do CRRT through it. You can add a stopcock, a connector with a stopcock to it, but if you do, guess what? You void everything. So anything happens to that system, even if it was not related to what you had done, you put a connector in it, and something happens to the oxygenator that's completely unrelated to that stopcock, they void they're not
Really?
responsible. Their responsibility is then on you because you've modified their system. Can't do it. Clamping the wired portion of the pump head failure, that's another one. Clamping the wired portion of the cannula, breaking a connector or stopcock port, turning certain stopcocks the wrong way. We discussed that. So the reason, going back to this slide, that this says what it says is because of that reason. The bedside nurse who sits can do Centrimag, can do Cardiohelp, but can't do the Rotoflow, and also with our system that we have, because we have a lot of access for that. So let me show you this slide. Now, this is an ECMO platform, and that's a Cymed oxygenator, actually a true membrane, the only true membrane that's out there, because the ones we use are all microporous hollow fiber,
Right.
but these are a true membrane. But what do you see about this picture that concerns anyone on the panel? Anyone on the panel? Can you see it?
Yeah,
Look at it carefully.
definitely see
Can we just show it?
one of the lines is awfully close to the floor, and that's a potential hazard.
Yes, if you look right here, yes, that on the floor. And look at the lines right here coming up the bed right here, near the bed rails. Everything is in a position that is here. Can you put the slide back up, David? Because I'm describing the slide and nobody can see it. There it is. Okay, so all of these lines and that line on the floor, this is just a recipe for disaster. It's waiting to happen. Now this circuit may very well, he's got a lot of pressures. He's got two pressures here, right here and right here. I can't see some of the other stuff he has, but this is where his drive mechanism is down here. And it looks like he's actually, I think he's using a roller pump, I'm not
Yeah,
sure.
that is a roller.
But nevertheless, you know, roller pump, centrifugal pump, I prefer a centrifugal pump, frankly. But with that said, I don't like this. It may be a good circuit. It may be very good at doing what its job is supposed to be, but it's sloppy. It's waiting for something bad to happen. And it makes no sense to me whatsoever. Now, I don't know who these two fellows are, and he's probably, if he ever sees this, he's probably not going to be real happy that I put this picture up here of him. But what do you see about this one that bothers you?
Well, you've got the venous line on the floor again, but this time there's an access point.
There
So
is.
That could be a potential hazard.
Oh, here. Yeah, can you leave there? Is there any way to change? Can he change the camera with that slide still there? Is that possible? I'll do it like that? Yeah, so he can see who's talking. Or broaden it out and get everybody. It doesn't matter. But okay, so let's go back to this again. So you have this here. the venous line's coming down, here it's on the floor, and here's one of these pigtails with a stopcock and a syringe. Now, it's good they have the little pigtail attached to it, which is good, but if this thing opens up, this line right here is under, as I said, tremendous negative pressure. Now, he's got a syringe on it to try to block it right there, but if somebody steps on it and cracks it, and don't tell me it can't happen if the patient's family comes in there and hasn't seen this patient yet and is frightened to death and wants to get up there close to them, that can't happen, because it can happen. This is, again, it may be a very good circuit. It may work very, very well. I've never really understood why everybody wants it on the ground like this, but they do it supposedly for air. I don't think it makes any sense. But regardless, this system here, again, may be a good circuit, but it's not done in a way that I would advocate for. And then you have this. So let's look at this one and tell me what you think about this one. You've got your venous line here. It's coming down, going right into your centrifugal pump, comes out here, goes into your oxygenator, out of your oxygenator, straight up, and back into the patient right there. And looks like it's attached to the bed with a bar. Here's your power line. Here's your oxygen line is right here. And here's your blender right here. So my opinion is this is actually a pretty decent circuit.
Decent setup.
Yeah.
But what do you notice? This circuit, the way it's designed, without necessarily spending $13,000, okay, now the oxygenator's a little pricey, but it doesn't matter, let's just hypothetically say. Would you say this is a system that a nurse taking care of the patient, nurse at the bedside, would have some confidence in being able to use without there being an issue?
Well, I don't see any access points, so
There aren't any.
I would say if they're put in that situation, that's the safest.
So versus a Centrimag or a Cardiohelp, which is $14,000, you can do this for about $2,000 and have the same thing. This is essentially the same thing because you don't have those access points.
Right.
But again, they've got both. They've got a femoral vein, a femoral artery. If they do need to do anything else with this patient, it's going to require them placing either a right IJ line or something else. And obviously, this patient is going to be anticoagulated. You're not on ECMO and not be anticoagulated. So here's what I'm talking about. Now, this is a little more complex system, but this illustrates why it's so important sometimes to have the ability to have access. The one disagreement that I have with this circuit is that the stopcock is right on the connector. That's dangerous. But this is a distal perfusion catheter. So this patient has a cold leg, and in order for them to get blood flow, they've taken a perfusion catheter, a little small gel cath, and stuck it into the SFA so that it flows distal down the leg, because this cannula right here is blocking the distal perfusion through the femoral system. So if you don't have the ability to access, you don't have the ability to do this either, which again can be quite a problem if you have a cold leg and a viable patient on ECMO. You can see here that they have some ports here. These are Lure locks. They can come off and create real problems, but they did double tie banded all of their connection points for the circuit. So I thought that was good up here as well. So I thought that was good, but this is a pretty complex system. This is VA VV. So this is a double. It looks like it's VA. No, it's VA VA. So they have veno. Let's see here. Here's a vein coming out. This one's going here to this one. Yeah, that's blue. So it's double venous and double arterial. So it's VA VA. So here's a slide sort of illustrating all of the possible configurations, and it's not all of them, but it's a good portion of the configurations you could have if you're trying to do ECMO. And again, if you're the nurse at the bedside, if that's the direction you're going to go, I don't really advocate for that. I think that the ECMO specialist is really the way to go. I think but the nurse ECMO specialist, I think, is what we're going to need in order to manage all of the ECMOs that are coming for the future. I've said that so many times sitting here that people are probably tired of hearing me say it. But this is some example of that. And in reality, if you have the Cardiohelp or the Centrimag, you can do double. You can do RV and LV support. But the Cardiohelp, you would just need 2 Cardiohelps in order to be able to do that. And there's not a whole lot of hospitals that have that, especially in the community setting. But those, in order to make it appropriate for the nurse at the bedside, would have to eliminate all of your connecting points, all of your access points, all of your infusion ports. Everything would have to be gone. And when you start adding these lines in, these require Y connectors to be cut in, and all of those Y connectors are not typically part of any manufacturer's built system. So something to be considerate of. And here's another example, just very quickly. You can see this is a baby, but adult, it's the circuit. What I don't like about this, obviously, is you have a pressure monitor here, and that's, again, the negative side. I don't think you need that pressure monitor there. If you're well-trained as an ECMO specialist or a perfusionist, you can see what it's doing and feel the line and know whether or not the pressure is low or high. It has this bridge. All of these stopcocks are right on the connecting points, and they have some more down here. These things are all extra luminal, so that's not really a problem. Temp probe and stuff like that, and the flow probe, transonic flow meter, air bubble detector. But the pressure monitor obviously is internal to the lumen it needs to be. I just think any of those things and the other things, the manifolds that I see, I don't like any of those things in my system. I think all of these things are an issue with multiple, not just accidents that can occur, but they get dirty. You run blood in them, and then you're not running blood in them, and the blood sits there. And if you have a patient who is on ECMO and who's septic, now you have stagnant blood that's infected. You're treating the patient, but the circuit has all these areas with this blood that's not going anywhere. It separates, it looks like hell, and it's infected. So you're clearing the patient's infection, but you keep adding infection to them. It's never really made a lot of sense to me. That's why I think we should change the circuits, frankly. I mean, nurses change their IV tubing every 3 days. 3 days. Mm-hmm. And we'll leave an ECMO circuit, the same ECMO circuit on. And they change theirs, and it just has fluid in it. Mm-hmm. And we have blood in ours, and they'll leave it for 15 days, 17 days, 20 days. I don't know that I think that's smart. No study's been done on it, so it's an opinion. But the question is it more risky to change it? So what's the risk-benefit ratio? Is it more risky to change it or more risky to leave it? Which is it? And of course, I believe if the patient can tolerate the change, I don't think every 3 days, but every 5 to 7 days, I think it should change. What's your opinion on that? You have an opinion?
I think you have to think about what you're trying to protect from. Like you said, if the patient can tolerate the change, then changing it, could be something that we make a part of, practice. But if they can't tolerate it, you're stuck with it until it fails. True.
That's true. That's fair. But probably better to change it before it fails, so that it's not you have more people there. You can plan.
Right.
So I probably not want to wait until it failed. Carol, what's your thoughts on that?
No, I agree. And I think anytime you, not tamper with per se, but like you said, anytime you change something or mess with something, you run the risk of other complications or things. All right. So again, you have to weigh the pros and cons.
Well, what do you think? I mean, do you think a blood circuit that the patient's entirety of their blood circuit, their blood volume is going through essentially every minute with all of these points, and if I go back to this slide, I think it's a better slide, with all of those connectors, and then think about the oxygenator right there, and there's dead space in that oxygenator there as well, where blood is stagnant, all the connections, blood is stagnant, and it sits there for, what, do you think it should be there for 15, 20 days?
What's the infection rate on patients
It's
on
a good
ECMO?
question. I don't know the answer to
What does
that.
the evidence say? Well, I
The
mean,
evidence doesn't say anything.
yeah.
There really isn't. In fact, Matt's going to be on, and I'm going to ask him what he thinks of the evidence. Good. Okay, so let's go. Let me get through mine, and I think some take-home thoughts. The simplest is usually the safest, but the simplest may not be the most effective. The more connectors, stopcocks ports you have, the higher your risk. The more connectors, stopcocks ports you have, the more you can do with it. So there's a dichotomy there. There are events that are unrecoverable, no matter who is at the bedside, and guarding against those is imperative. Minimize risk by strategic line lengths and placement. Keep it clean, not your Venous line dragging on the floor with a stopcock waiting for somebody to step on it. And think it through. That's all I can tell you. Think it through. Check it, recheck it, and then recheck your check and have somebody come check your check.
Behind you. Yeah.
Don't ever trust yourself. Don't ever trust anyone. Always recheck. That's my view. And I think that's my last slide. Okay, let's go right into, let's bring Matt Warhoover into the show. Matt, how the heck are you? There he is.
Thanks for having me.
Hey, bud, how are you? It's nice to see you again.
Thank you.
You're always so smiley. You must be really happy out there at Vanderbilt now that you have Colin Barker. Is he there yet?
Well, I don't think he's quite there yet, but he is. He's on the way up.
I think he's going to do really good things with you, man. I think you'll enjoy working with him. He's a really good fella.
Yeah, I heard a lot of good things about him.
Now, Matt's been with us before, but let me give just a quick introduction, please. He is not only a perfusionist, but he's the Associate Chief of Perfusion at Vanderbilt University in Nashville, Tennessee. He holds a Master's of Science in Perfusion, a Master's of Management in Healthcare, and did his graduate coursework in biochemistry and mathematics, and Bachelor of Science, with a major in civil engineering. He has a tremendous ECMO experience, and I think you're going to really give us some good input on the various tools that we can use to deliver ECMO, and then after our quick break, give a talk on some ECMO staffing models, hopefully that'll tie into what I'm talking about in terms of ECMO growth and how are we going to manage all of this as perfusionists. I think it's a real problem. But before you get started, I have that one question that I have to ask you, is what is your view of keeping circuits on patients who were put on it for ARDS secondary to sepsis and leaving it on for more than 7 days? I mean, what's your opinion on that? And is there any evidence on that?
Well, I think you're right. There's no evidence out there. I have to agree. I'm not a big fan of the pigtails or even entry points into a circuit. I think you're just asking for trouble. And I think to your point, you've got the stagnant blood flow. You clear the infection in the patient. The next thing you know, it rears its ugly head again 24 hours later, and you don't know quite why. And you're running people onto CT to get scans to see what's going on. Where is this pocket of infection that we're missing? And it's not in the CT scanner. It's laying right outside the CT scanner. I agree with you. The concern that I have about changing them out, and anecdotally, I can tell you that we can't really predict which patients this happens to, but regardless, when you change out a circuit, many times you'll see a Sears effect on the patient, and they'll get set back, especially your VV patients. They'll get set back 24, 48 hours. It's almost as though that they get the Sears effect, they dilate back out, you're back on suppressors, and really you just give the volume back to maintain your intervascular integrity, and then you over a period of the next 24, 48 hours, you take that volume back off. So I don't think it's a free lunch changing out the circuits. I have to agree with you. I think there's a risk-reward benefit. I'm just unsure of where that's at, and it's not very predictable on what patients and to what severity that they actually get that serious response. Some patients, they don't get it, no problems at all. Other patients, you think, oh, they're relatively, in good shape. We think we can get them off in the next 2 to 3 days. The oxygenators get a little crummy, probably need to do that. Next thing you know, you set them back and they're on for another 5 days.
Yeah,
the other thing I will
interesting.
comment about is that it is well established that there is a protein layer that gets laid down on that surface, and it's a relatively large surface on those oxygenators. Even the newer ones today, they're more efficient than the previous generations, but the surface area is still significant, and we do see a drop in in the intervascular protein level of the patients after you change these out. So that's, I don't know if I solved anything, but that is my anecdotal opinion.
No, I think it's good. My experience has been that when I change it out on patients, my experience anyway has been that they sort of pink up and look better for a short period of time. Now, it's not long-lived. They kind of eventually dribble back to where they were, but I haven't seen that where they dump completely. But of course, you see a lot more ECMO than I do. And I'm going to look for it more. But, we have, what we are doing, Matt, is, and I'm so sorry, I know we're going to get your talks done, but very quickly, we have basically two options. We have, if we think the patient's going to be on for less than 5 days, we will go ahead and put them on with a polypropylene fiber lung and say, you can't use propofol. We tell them up front, if you're going to use propofol, we can't use this. But if we think it may be 7 to 10 days, we go ahead and use the PMP fiber, and that helps to eliminate that, or if they insist on using propofol, or if they're hyperlipidemic and we know it, we'll go ahead and go that direction. But even with the PMP fiber, I think personally, I'd be more inclined to want to change it, but I'd like I hope somebody looks at this, and it'd be great if you guys could, because you're in a perfect situation to do it. You have a lot of patients, and I know that you have nothing but a lot of time on your hands. You're not doing anything over there but hanging out. So with all of that said, let me let you go ahead and do your talk, and I'll be quiet.
Okay. So David, we're going to probably do the same thing we did before, where you'll pull it up and we'll just do next slide.
Yeah, I have the slide.
So I did want to comment. Yep. I did want to go to talk to you about. You touched briefly about the cost. I apologize. I just caught about the last 20 or 25 minutes of your talk, but I heard that you gave some financial numbers. That is one thing that I didn't want to address in this talk, and the reason being is I am from Nashville. There's 3 other private groups in town, and then there's of course Vanderbilt, and then there's a very large national perfusion and healthcare corporation that's based just 7 miles south of us. And so within just the city itself, I would say there's at least 5 different avenues to buy capital equipment and disposables. With group pricing, whether you're a national perfusion or healthcare company, or you're a healthcare system across the country, or you're a big level 1 medical center, or you're associated as a perfusion group with the purchasing power of a hospital, or you're standalone. There's a lot of different ways that pricing gets done within capital equipment and disposables, and the combination bulk pricing. A lot of different ways that they make packages for people individually. So I didn't want to go down that route. I'm glad you touched on it, but that's one thing I did not touch on this was the cost of these products, because I just don't think it's a very accurate. I think one person's cost can be much higher or much lower than what some people are going to find out there. So that's kind of I guess what I wanted to preclude first.
That's right. That's right. It's called what's that called when you what's that? You're the financial guy. What's it called when you agree on a price? The market value, fair market value. Fair market value. Fair
Yep.
market value is
Capitalism.
fair market value is what you can get somebody to pay for something. That's fair market value. There's no such. It sounds like such a neat term. It's fair market value. That's just what you agree to buy it for. It's kind of a crazy term.
All right, well, we'll just jump right in. So
Okay.
next slide.
Oh, I'm the slide guy here.
So additionally, I wanted to say that I don't have any financial disclosures to any of these companies I'm talking about today. I just wanted to lay that out there right away so nobody got any ideas that I'm pushing one or the other. So next slide. And, what we're going to do is we're going to talk about, primarily we're just going to talk about the pumps, and we're going to talk primarily touch on a little bit of the oxygenators that have some affiliation with some of the manufacturers here. But if you just click next slide, I'm essentially going to eliminate everything else but these three topics. And so we'll get right into it. Next slide.
Next slide.
I did it. Oh, next one after this? Okay, hold on. It's not.
Yeah, sorry about that, Joe.
Okay, I'm trying to make it change.
Oh.
There. Okay. There, is that it? Nope. There. Okay, right
That's it.
there. There you go.
There we go. So essentially, and I did want to bring to the table on this discussion that there are 2 or 3 different companies out there that are not FDA approved. Some are available for compassionate utilization, and then there's some that are actually trying to get compassion utilization, and then there's even one that's available just as a fixed trial. That's a couple of the centers across the country, but these are primarily the devices that are going to be available in the U.S. I would think in the next 3 to 5 years. Many of them are already available, of course, but there are a couple that are coming down the pipeline. They're going to be here really, really soon. Additionally, a couple of these companies also have some devices that I would think within the next 6 to 12 months, I think we're going to get a couple more products from some of these companies, primarily Abbot. I think Medtronic is going to have another component, and I believe Sorin will also have another oxygenator and or pump available here the next year. But I just wanted to give a brief overview of what the world, what the world is seeing from an ECMO standpoint. And we know in the U.S. we come a little bit behind the bell curve with this technology because of our FDA and the regulations it takes. But I did want to give an overview of what's available worldwide. Next slide. So we'll jump right in. I did this by alphabetical order. We've got everybody's pretty. You talked about the Centrimag, Joe. Everybody's very familiar with this. This technology has been out there for years for the perfusion community. They've got first generation, and now they've moved on to the second generation consoles. The first generation is up in that upper left-hand corner. The second generation is the upper right-hand corner, and then they've got a monitor that they've added on that is a little more user-friendly touch screen. The thing that is most unique about this device is that it is completely frictionless. The magnetically levitated impeller allows one of the few technologies that is truly frictionless and is a floating impeller. And as far as from an ECMO standpoint, what I don't like about this is that there is no backup on the backup hand crank available. So when you're transporting, you always have to have 2 consoles with you, because if a primary console goes bad, whatever the malfunction is, electrical, mechanical, with it in that console, there's nothing you can do other than to change the console out. The lower left-hand corner shows you've got the 2 primary consoles up top. You've got a backup down below. That's more or less a BIVAD situation. And then the lower right-hand corner, that's their transporter device. You can see you've got it's really, really nice. I would say it's probably right behind the Cardiohelp, which we'll talk about later, as far as transporting the circuit. It's got a wonderful setup to where the console's protected. It sets up nicely. It's got a couple wing arms on it that can lock it to the bed on a handrail, or it can actually be held. It's not that heavy. It's about 22 pounds. It's got it's all inclusive. It's got your oxygen bottle tank, as you can see on the left. The console slides right in to a slot in the middle, and then you've got your oxygenator and your heat exchanger on the right-hand side. It straps in. It's designed primarily for either a Maquet Quadrox, or you can get one of the affinity oxygenators. It's got multiple different straps and more or less holding devices for the oxygenator. It's a great inter and intra facility portable ECMO device, and the only, like I said, the only downside to this is it does not back up crank. And I said I wasn't going to talk about cost. I wasn't going to talk about exact cost, but the pump head is quite expensive, as we all know.
Does it have
Next slide.
Matt? Does it have a backup battery pack to it?
It does have a back, so it's got an internal battery that the first generation is 60 minutes, and the second generation is 120 minutes, and that's each in the primary console. Additionally, they do have, as as technology's grown, we all have those battery packs for our phones or for our computers. Mm-hmm. They do have approved external battery packs that can extend your portability range without draining the entire internal battery. So there is a way you can actually put a external battery pack on it, and it's not necessarily an Abbot Thoratec product, but they do have approved battery packs that go along with it that you can purchase extra if you need to make an extensive trip without some sort of an inverter in an ambulance or an airplane. You can get longer than the 120-minute internal battery life on the second generation.
Okay.
Next slide. And please, let's. This is a discussion. This is not a lecture. So if we've got anything from the panel, please stop me at any time. So and primarily, the Centrimag, it can also be a VA. It's the VA or a VV ECMO system. Either one is capable of doing this. The Hemolung by Alung. This device, I believe, is going to be probably the next device that gets FDA approved in the U.S. They did a 30 hospital. They're actually doing a 30 hospital trial that was announced just late last year. It's the Venous trial. This is strictly for ECOR, which is a form of VV ECMO. It's not designed for oxygenation. You do get a little bit of a component of oxygenation with it, but its primary role is to take off CO2 in the COPD patients or post lung transplants that's having trouble, or pre lung transplants that are awaiting transplantation. It removes between 25 and 50% of your basal metabolic CO2. The cartridge inside of it, it's kind of almost looks like a cell saver. I want to call it an oxygenator. They call it a respiratory dialysis cartridge, but for all intents and purposes, it is an oxygenator. It just doesn't oxygenate as well as it should if you compare it to the other ones. It stands stationary in the device, and the cartridge inside spins. That's what gets your more or less. And there's just a constant blood in, blood out of a single pass, and the cartridge just spins within it. Very, very. It's been used, multiple different places across Europe and Asia, and they did one of the largest studies of this is in the UK, and it really eliminates the surface area on this device. It's very low impact, and because of it's almost like a CRT machine. You don't have to anticoagulate fully. It's a very unique, kind of a niche product for your CO2 retainers. No hand cranks available. The intra-facility mobility, you can do it intra-facility, but not extra-facility because it does have a very short battery life, and it's just, you can see in the picture, it's kind of a large large piece of equipment that just not going to transport very easily if you have to go from facility to facility. Mm-hmm. Next slide. So this is the flagship of the worldwide ECMO transport as we know it. It's the Cardiohelp from Maquet. Additionally, the Rotoflow, which is was their first generation pump, they upgraded them from the HL20. At the it's just, both technologies use the Rotoflow pump. It is a single point bearing. It is magnetically driven like all the other devices, but that design has not been changed since the HL20 came out. It does have a hand crank for both devices. The Cardiohelp, of course, like I said, it's the flagship. It's probably the platinum standard when it comes to ECMO transport across the world. Once again, to your point, Joe, when you talked about it, it does come with a hefty price tag, and as a 90-minute battery life, it's very compact. Allows you to whether it's a helicopter, ambulance, fixed wing, and then once you get into your hospital, or if you're staying within the hospital, they have added this cart. It's very convenient, very low footprint size, and the only downside about this is when it comes to the Cardiohelp, anything that needs to be changed out, whether it's the pump head, the oxygenator, even a line, you have to change out. It's an integrated system, so I would say that's the drawback on that system. It's a one and done.
One and done, yeah.
Next slide.
Exactly. Well, that too, and I was going to add to that
Yeah.
for a program that is just using the doing ECMO, but is not going to be transporting their ECMOs via either air or some other means, but they're going to actually be keeping them. And if anybody's going to take the patient or they're going to transport it, they're coming to get the patient with a helicopter. It's a great transport ECMO. I will give them that. There's no question about it. But I don't really feel like that's appropriate for just the standard ECMO program. I think it's overkill. No pun intended.
I would agree with that. The upfront cost, and what the Maquet people are going to say as well. What they're trying to do is they're also trying to, we're going to talk about that a little bit later on tonight. But the staffing issue, because of the bells and whistles and the safety features, and they are designing, they've designed that mechanism to not have a perfusionist be bedside with it,
right,
and potentially even in-house.
Right.
They're offsetting the cost of an expensive FTE in-house, and trying to eliminate that, because we all know perfusionists don't grow on trees. They're a high commodity as well, and so these smaller programs that what they're trying to do is you don't necessarily have to have a perfusionist in-house. You don't necessarily have to have a perfusionist potentially do anything but change it out, and there's some depends on what kind of program you're running. We're going to talk about that later. Is that it's trying to make it it's perfusion, it's ECMO for dummies, if you will, and they're trying to make it very simple, and that's not a derogatory say when I say for dummies. They're trying to make it simple, trying to make it safe, and they're trying to utilize the least amount of resources when it comes to man hours, physical man labor or person labor involved with it.
Well, and that's a very, very good point. In fact, I'm glad you brought that up, and I'm glad you don't mind me talking. But I think that in terms of the physical operation of the device, you can turn it on. The physician wants it at 4.5 liters. You can turn it on 4.5 liters and make it run. That's the nurse at the bedside. But when the patient's unstable and the thing starts to chatter, and is it the pressure? Is it the, and not getting that stable? Is it the pressure? Is it volume? Is it both? Is there something else going on? Managing that, I think the nurse at the bedside needs to take care of the patient. And I think either the perfusionist or the nurse ECMO specialist needs to take care of the ECMO. It's a team effort. Because as long as it runs smoothly, no matter how simple you make the system still has to be potentially adjusted. You need to be and know what to do in the circumstance as it's occurring in order to make the thing continue to run, especially if you have a patient with low anticoagulation and all of a sudden your line starts to jug and you get a tissue that's now trapped within the cannula. Does the person, the nurse at the bedside who's now managing a code, know to turn the flow all the way down to 0, let it release, and then slowly bring it back up again? So eventually they figure that out, but they're managing the patient, but it took them too long, and now the whole thing is thrombosed, and you still have the same problem. But that's okay, because you can still spend a lot of money and get the next Cardiohelp cartridge and stick it in there, and everybody's happy. Okay, next slide.
Yep. And so this is another investigational device. It's not FDA approved yet. They have used this in a couple patients within the U.S. for compassionate use. You can do VA and VV and ECMO with this configuration. It's primarily the Medos Delta Stream pump combined with the Novolung oxygenators or ECOR respiratory dialysis more or less devices. And you can see the platform, it looks a lot like the Rotoflow as far as the footprint of the Delta Stream pump. And it looks a lot like all the other devices that we have, whether it be the Biomedicus or the Sorin. It's a remote head that you have. But what is most interesting to me is that they have more or less designed, the Novolung team has designed multiple different oxygenator-like products to more or less give you customizable what you need. They even have for small adults, they have them for peds, they have them for large, if you need oxygenation and CO2 removal. They also have it if you just need CO2 removal. And once again, kind of like the ECMO machine with the Alung, the Hemolung that we saw before. The far lower right-hand product, that's a pumpless system. What they do is they have an arterial graft that is sewn onto the femoral artery, and they more or less put a graft on a femoral vein or cannula, and it utilizes the patient's blood pressure to actively pump across that membrane for ECOR. Mm-hmm. It's
very low.
It works very well.
Very low resistance through that thing.
Very low resistance, and once again, these are your primarily what they're using them for are people that are either not transplant eligible but go into some sort of a hypercarbic scenario that they just need to get the patient back in line in their blood gas management, or these people that are on lung transplant lists that they don't necessarily want to throw the entire ECMO circuit at them. These can be easily managed. Very low anticoagulation on the pumpless, and then the middle does have the small pump with it. That is primarily for if you have to need more than just a pump less. If you need, or you sort of a cardiac portion that it really your cardiac function may be a little bit compromised, and then of course to the left, that's the full component of the XL lung kit. That is the equivalent of the Maquet Quadrox or any of the other mainstream ECMO-like oxygenators that we have in the U.S. But I really look for this company to be a lot like the Tandem Life, or we're going to talk about a little later. They have adopted this where it's a not one size fits all. It's kind of like appropriate, very similar what Terumo did with with their ECMO, with their oxygenator sizing.
Yeah, the Capiox.
That they did.
FX.
It's one
The
prescription
FX,
yeah.
thing.
Yeah, prescriptive. They call it prescriptive. Oh, we lost Matt. Hold on, Matt. We lost you. Hold on.
Oh,
Wait,
you
lost
there?
your voice.
There, you're back.
Say again. Say something.
Okay.
Okay, yeah, you're back.
Yeah, it's a lot like what Terumo did with their prescriptive oxygenation.
Mm-hmm. Mm-hmm.
So next slide. So and this is the other, besides Medtronic and Maquet, this is the other company that's pretty mainstream out there. LivaNova Soren SCPC trolley. And then most recently, LivaNova has purchased the Tandem Life, Tandem Lung product line from Cardiac Assist. Cardiac Assist had the Tandem Heart for quite some time. A lot of places in perfusion communities were used to this. LivaNova recently bought it. That has the VA, VV ECMO platforms. I'm going to start with the Tandem Life and the Tandem Lung. The problem with the Tandem Life, Tandem Lung product line is that it is a one-stop shop. You get the cannula, the pump, and the oxygenator all included in one kit. There is no a la carte, and it is a significant cost for opening that kit.
18,000.
Yep.
And they won't sell
Yep,
the cannula
it's,
separate.
it's-
But in Canada, they can buy the cannula separate for 11,000.
Really,
Yeah.
I did not know that.
Yep. So go to Canada Medical online and buy the cannula separate. No, I'm just kidding. Try it.
But as far as a portability, it's got a 60-minute battery backup once you unplug from direct power. Once again, it is magnetically driven with a floating impeller, similar to the Centrimag. However, there is the lubrication port that's underneath that is required for that. IV pole mounted controller, and they've recently come up with this patient vest. And the portability for this is outstanding. It really is. You're able to walk the patient. It is second. It is second to none. The portability, inter, or just letting the patient walk out into a courtyard outside. It's very, very, very convenient. It's no different. All you have to do, literally, is take an IV pole and an oxygen tank. It's no different than if a patient had an IV and was on some sort of nasal cannula requirement.
Now, can I ask you this? It has no heat exchanger,
Yeah.
right? It has no heat exchanger.
It has no heat exchanger. That's correct.
Now,
Yep.
I've also
Nope.
heard that it's a little bit underpowered. So if you had a patient, let's say, who was in septic shock and had SVO2 of 45, maybe 40, 45, are you going to be able to get enough power out of this thing to treat that patient? Or is it more for patients who can be ambulated that just need primarily CO2 removal with some oxygenation?
Well, it's funny that you mentioned that because you would think LivaNova, the Soren product line, you're thinking, well, why would LivaNova want to go ahead and purchase this? Because it's kind of a it's kind of a competing product.
Mm-hmm.
But because what you just touched on is exactly why they purchased it, right? So the Soren SPC and the trolley, if you need the workhorse to provide for a septic patient or someone that truly needs ECMO, meaning that they just don't need a little bit of support, they are not your pre-transplant or just let them limp off or limp into a surgery. That's why I think LivaNova purchased it, is because you're exactly right, Joe. This does not have the horsepower to maintain, nor does it have the heat exchanger that you're going to need for long-term support.
Mm-hmm. But I think they bought it for the cannula.
It's a market. It's right. It's the market as well because they've got it. It is a and the the functionality of actually, with using the old tandem heart catheter that you actually goes, across the septum,
Right.
to where you're utilizing the patient more or less as an it's an LV device at that point.
Mm-hmm.
That's the other, the other diamond in the rough for that company.
Yes, absolutely.
So moving on to the Sorin SPC with the trolley kit, we have a homegrown system that we actually use as a transporting device. The design, it isn't bad. It's the handles on the main pump or the main driver itself, also the same size as what the quick clamps are. So you're able to get the remote driver head and the control panel all on one device, and you can take it. You don't get the ERC, the bubble detector. You can get with you. It doesn't need a freestanding holder for you. But the whole idea, will it work in a transport? Yes. Is it as convenient as some of the other product lines, the Cardiohelp, the Centrimag? No, but it also doesn't come with their price tags either.
Right.
So to your point, these centers that just need to provide the support, and they're going to hold on to them. They're not going to transfer them, to a different place. They're going to wait for somebody else to come get them. This would be my recommendation to get your, as far as a platform off the ground. This would be my choice of product to start your program, because once again, there's many things that come into your program. We're going to talk about that later, whether it be staffing, a physician champion, referral-based volumes, census, a lot of things. A lot of people want to open ECMO programs. I mean, it was very lucrative until a couple months ago, as we talked about in an earlier session.
But I think
there's
that's
a lot of things
I think that's going to
go
change,
onto that.
though, Matt. I think that they're going to adjust that.
Yep. Yeah. But to the point is, there's a lot of different variables that go with starting an ECMO program, and capital equipment costs, is not insignificant. And so, starting a program, this isn't the worst platform you could go with.
Yeah, I agree with you, and you're absolutely right about that. You brought up some really good points. Having a physician champion, having the right referrals, having the patients referred for ECMO before they become so damaged with barotrauma from the ventilator, or so poorly perfused that their periphery is already necrotic from all the pressors and nobody's done anything up to this point, and basically taking a salvage now and trying to do something with them. But you're right. Everybody wants to start an ECMO program, but starting an ECMO program means all of those things we just mentioned, plus people that have actually spent the time to learn how to manage the patient on ECMO. Because just putting them on ECMO and walking away and hoping that everything turns out okay doesn't ever turn out well. You have to actually take care of the patient.
Yeah, I would agree that the cannulation process, although it is important, because if you have a poor cannulation, or you have a cannulation, error, or an obstacle, you're going to deal with that throughout the entire run of the ECMO. The patient's ECMO run. But cannulating is probably the easiest thing of doing anything with an ECMO patient. It's the management strategy is the most difficult.
Absolutely. And knowing how to. Exactly. Okay, so let's see. Next slide.
Yep.
Okay.
Next slide. Oh, there was one other thing I would like. No, we'll go next slide. Sorry. So the BioConsole, this is the Medtronic. They had the 540, the 550, and now this is the 560 here in this picture. Hand crank available. Once again, the design of the head very similar to the Rotoflow and the Sorin Revolution. It is not a truly frictionless surface. It has a ceramic bearing in it. What is very interesting about Medtronic is they have decided to enter the market, and more or less they don't care what device you want to buy. They have retrofitted an adapter plate to go to the other manufacturer's consoles, so you can use their disposable. And so I think that's a pretty what I would say forward-thinking type engineering strategy, because the capital equipment costs once you purchase it, a lot of these times you're tied in to the manufacturer that you've bought the capital equipment with. Medtronic has gone a little bit beyond that and go, you may have already made a decision to go with a different company, but that doesn't mean that you can't use us on our disposables. And I think that's really, really novel.
I agree.
And like I said, this is probably the most, I think most people in perfusion have seen the bioconsole. Doesn't matter what model it was, but this console hasn't really changed that much in the last 20 years.
20? I remember it from 1979.
But, I didn't want to date you, Joe.
Thanks. You were right there. You taught me.
And so the final slide. So the overall, I just wanted to go through the last column is my own personal opinion. I haven't transported. I can honestly say I haven't transported the Alung. I've not transported of course the Delta Stream, but everything else I have transported, and that's kind of my star ratings. The higher the star rating, the easier it is to transport, whether it be inter facility or intra facility. The Cardiohelp and the Tandem Life and the Tandem Lung, they're the easiest to transport. And then the Thoratec Centrimag, it's a little cumbersome, but it's right there. And then finally, your Sorin SPC and the Rotoflow and the Biomedicus, they're all in the same category. And I just more or less reviewed the summary of what our slide, previous slides were, into one-stop shopping on what we covered today.
Okay, very good. And let's see. Oh, that was it. That was your last slide. Okay, very good. So
That was it.
So yes, that was good. I enjoyed that. So you wanna discuss this at all? Anybody wants to call in? They can call in. You can open the phone lines real quick, or maybe a few minutes, and then we could make a 2-minute break. How much time do you need on staffing model?
Oh, well, that's the funny thing. I think the presentation isn't that long, but I think the discussion can get lengthy because I think there's some highlights of some of the tenants that some of the pitfalls that we've seen here at Vanderbilt, of the different staffing models that we've tried. So as far as the presentation, probably 15, 20 minutes on the presentation, but I think you could talk for hours on that subject.
Well, let's do this. Let's do, if it's okay with everybody on the panel, if it's okay with you, you want to take a quick 5-minute break. We can use the restroom. I need to go. Okay, I'm sorry, I'm old, and I didn't wear my Depends, so I really have to go. And then we'll come back. You can hit that, and then if somebody wants to call in, they can call in and ask anything they want about the systems or about staffing or either one, since you're going to be here for both of them anyway. Would that be okay with everyone?
Yeah, sounds good.
Sounds good. Matt, you good with that?
Sounds great.
Okay, so we'll take 5 minutes. Okay. It's on, okay. And welcome back, everyone, back to PerfWeb 24, part 2. And, no, part 1. This is the end of part 1. Yeah, it's not part 2.
Part 2's tomorrow.
Yeah, but I do like your first slide. Put that first slide up of Matt. I like that. It's like an old chalkboard.
Yeah.
Oh, that's a presentation,
Yeah.
Yeah, and I just wanted that wasn't by just chance, because I kind of the preface to this is that this is you know, kind of whether you're doing football schemes on a chalkboard or basketball, or you're just, you know, you're in the drawing room, you know, of an old schoolhouse, is that there is no exact science to this, and what works in one place, others can all the ingredients in New York City. We got Dr. Maquet from New York Presbyterian. You can have, he ran a wonderful program up there. He had all the right ingredients, all the components that, you know, that ran a great program there. And, you know, we in Vanderbilt, you know, we had a program, we have a program now, but just because what cake works in one place and how you baked it, you just can't take that recipe and go somewhere else with it, because it's individual people, it's components, and it's, well, like we talked about, all the different ingredients to make a great program, whether it be a champion physician, the referral base, what your tolerance of the management is, you know, how many ICUs are you keeping these people in? Is it central located? Is it distributed across you know, all your ICUs within the hospital? There's so many characteristics to an ECMO program that there is not a cookie cutter model. And so it wasn't by design that I picked the chalkboard.
Okay.
So we'll get right into it. So the ECMO staffing models we're going to talk about tonight are perfusion-based, nursing-based, RT-based, and then a hybrid model-based. And the hybrid model is a combination of any and all of the three previous models. And I have experience with all four of them at Vanderbilt. Next slide. So the best way, I just wanted to outline more or less the pros and cons of every model. Once again, this is my interpretation of it. I can assure you, you know, people at Duke, Ms. Belladonna, who gave a great presentation at AMSECT on ECMO staffing. You know, her experience and interactions with different models is going to be, you know, much different than mine. And I think if you go to any large center, you know, that's doing 50 to 100 ECMO, how they do their staffing model. And once again, it's not to say that they're doing it wrong or you're doing it right, or they're doing it right and you're doing it wrong. It is what your environment allows you to do. And I think I think everybody's environment is what dictates what is a successful ECMO staffing model where they're at. So the pros in my experience of having perfusion is that you've got the you know, the highly trained people. They're specifically trained for extracorporeal support, and so you may or may not need ongoing competency training. I like to say that, you know, we have our competency training. If you're an integrated program that you know, does perfusion-based ECMO and you're saying perfusionist or day, you know, every morning you have a wet lab, believe it or not. And so the competency, these quarterly or biannual competencies that a lot of these programs are suggesting, I'm not saying that they're not warranted, but a lot of times, you know, in a large, robust program, they may not be needed. You can also provide your largest patient to FTE ratio. I just think with experience and the control and the comfortability of extracorporeal technology, that's what perfusionists know. And so they generally have a lot more comfortability with managing a larger ratio, in my experience. And then what goes along with the little to no ongoing competency training is your highest productivity ratio. And we'll talk about what that means in the next couple slides. I'll show you examples of what I'm talking about. The cons of having a specific perfusion-based ECMO model: it's very expensive. Availability of resources. Perfusionists, we are at a kind of a shortage in them. So to utilize and flux up and down with census is tough. It depends on what the model you're bringing, but if you're a private practice group, how do you manage for large census in a flu season? Do you hire locum work? That can get expensive.
Yeah, that's a very good. Dude, you brought up some very good points. We're going to be. I can't wait until we get to the discussion part, because you just tagged on something that's very tough.
Yeah, and so flu season, when you're for just a hospital-based program, it doesn't matter if you're contractual as a group or you're the hospital-based as you're an employee of the hospital. How do you justify people doubling their number of hours work week during flu season? And with most people being salary, it's tough to manage around that, and so you have to get a little creative with some salary and compensation structures. Once again, you overstaff. Perfusions can't be floated into other service line work. I mean, we all can hold a broom. At one point, there was that's how perfusion got started. It was OJT. It was people that had a knack at some sort of lab work or some anesthesia techs that were pretty crafty, and they got it, and so they just can't float us back into service lines like they used to. The other thing that is kind of a softer side is it's non-OR setting work environment. A lot of perfusionists, they got into perfusion because they didn't have patient interaction. Well, by the time they saw the patient, they were asleep, and when they're done, patient's still asleep. That is not necessarily the case with ECMO. It's a non-OR setting work environment, and there are some characteristics, there's some interactions, there's some personalities, and there's just interpersonal communications between other subsections of staff that you have to accommodate, and you have to kind of learn how to work with people other than just OR nurses and physicians and anesthesiologists. You have to manage those personalities, and you have to manage where people are coming from a non-traditional, non-perfusion perspective. And then finally, I think this is one of the biggest things. We cannot provide duplicate nursing role. So we can't help the nurse's bedside to give a drug, or if you're not an RN, and not all perfusionists. I wouldn't say that there are some perfusionists that are RN, but mostly perfusion can't provide that kind of role or detail. If the nurse has to leave, to whether give her a lunch break or a regular break, we can't fill that role, and that's one of the downsides of having a perfusion-based ECMO model only. Next slide. So the nursing-based ECMO staffing model, a lot of pros to this. You can get to the one-to-one. To your point, Joe, you talked about earlier, with a certain setup, with certain ECMO circuit design, and with some forethought, you can get that model to where the nurse is taking care of the patient and the circuit. Generally, on the con side of it, there usually has to have at least a 1+ model involved in that. So you have a nurse taking care of the patient and the ECMO circuit. You usually always have to have an additional hand on deck that is just for the designed just for and assigned to the ECMO program. You may have 4, 5, 6, 7, 12, 20 patients on ECMO, and you can have that 1-to-1 ratio, but you still have to have a 1+ model, whether it's giving breaks and lunches or just an extra set of hands in a difficult situation to manage through, whether it's an acute patient that is unstable, or if you have to actually do an intervention onto the circuit or onto the patient. Largest availability of labor pool of the three components that we have, whether it be RT, nursing, or perfusion. There are more nurses available to do this and to train into the ECMO specialist role. That is the best thing about this model. It is less expensive than perfusion as far as from a production model per hour, and I want to come back to that. They can be floated in and out into the nursing pool, and we all know that there's a nursing shortage as well. And so it is nice to flex in and flex out with the census of what the ECMO census is in your facility. And then they're already integrated. Most of your ECMO specialists are going to be ICU nurses first, and they're going to be ECMO specialists trained later. And so they already know the ICU. They're fully, they're fully in waters on how to get things accomplished, which is not exactly what perfusion knows. We have patients that we'll go up and see on balloon pumps or VADs, but we're more versed in the OR than we are in the ICU setting, I would say, in my experience. The cons, ongoing competency training. Two parts to this. One, you just have to have a competency checkoff. That's the nursing platform. That's what the nurse educators do, whether it's a CRT machine, a VAD, a balloon pump. They just have competency checkoffs, and that is non-productive time. Non-productive time in a hospital setting is expensive because you're not getting value directly like you do typically in the OR. When a patient's in the OR, there's a click. They're clicking, time, and time is money. In an ongoing competency training, that you have to account for that, and we're going to talk about that a little later. They're not specifically trained for ECMO, initially. That is kind of a misnomer, I believe. I said because if you can hold on to the nurse ECMO specialist and you can get them trained up and you can retain them, I think they do a wonderful job. I mean, outstanding job. I can't speak enough to that although I say this is a con, it's in the beginning. Getting someone that didn't go to 2 years of perfusion school or a year of perfusion school to have the background, they're not going to, they're not fully, they don't fully understand fluid dynamics. But I tell you, some of the ECMO specialists that I work with and have worked with, I'll take them in an ECMO setting over a new graduate out of perfusion school, and just because you can't replace experience. And so, although I put this on the con side, I just want to preface that. And then this is the one that's hardest for me. It's the con that we run into. It's the options to extend their career opportunities. It's retention. You get good people that are very intelligent people that you offer them a step up off of what their normal daily platform is as an ICU nurse. You go, hey, I think you'd be really good as an ECMO specialist. Let's invest some time, money, because you have the effort, you have the drive, you have the capability of doing this, and then you achieve that. The next thing you know, you have primed them. Whether it was you've primed them or they use that as a trampoline to the next step in their career opportunity and their career advancement. Some of them go to CRNA school, some of them go to PA school, some of them go to nurse practitioner school. Some of them go in and get their PhD in nursing. This is just a lot of times it's a platform and a trampoline for their next move, and that's what I found the hardest thing to manage with this nursing-based ECMO staffing model. Is the retention is really tough for us. And they are the most expensive to train because perfusionists generally are already trained, and so they're you hit the ground running. 30-day, if you hire someone new, you get a 30-day, orientation, and then you hit the ground running. You've got a nurse that has been an ICU nurse before, but now you're changing their role. And some people they want 100 hours, some people want 400 hours, some people. I've heard all over the board, it can take anywhere from 30 days to 6 months to get people trained. And once again, it's also based on your volumes, right? So if you don't have a large census and volume capable of getting the hours, it's tough to get people trained up in a kind of a short time frame if you don't have the ability to do that real time. Having someone sit with a proxy. And we talked about the general need for a 1+ model. So next slide. So the respiratory therapist-based model, this is the model that I'm least familiar with, but we do run it at Vanderbilt on the children's side. There are nurses that are over there, but mainly they're respiratory therapists on the children's side. Retention's much better than nursing, only limited by their degree, because with an RN, BSN, MSN, you can go in a multitude of different pathways for career advancement. RT, that's not so much, but also the advancement that you get, whether financial impact from RT to being ECMO specialist RT, in my experience, has been enough to retain people, and it's a game changer for people, so that they're very, very happy in their career advancement once they hit this level. There is a larger available labor pool, but once again, geographically across the country, we do have some RT, staffing shortages as well. Of the 3 staffing models, they're the least expensive labor force to have per productive hour. They can have a limited float capacity, not as much as a nurse, but they are able to float back in more so than a perfusionist. They also are integrated mostly in the ICU environment. They run the vents. They know that environment. They know those waters. They know how to manage the different personalities in the units. Cons on the respiratory service side, ongoing competency, very similar to what we talked about in nursing. Once again, not trained specifically for extracorporeal support, very similar to nursing. Similar to the perfusion role, they can't provide a duplicate nursing role either. They can't give meds. They can't step in for the nurse for a break or a lunch. They have smaller into FTOs, and they do a 1-to-1 in other models that I've known, whether it be Duke or other facilities, UAB that use respiratory therapists. Their ratios are smaller than for nursing and for perfusion as far as their staffing ratios. Once again, we talked about they're expensive to train, and once again, generally need a 1+ model. That we talked about, that they're very similar to the nursing staffing model. Next slide. And then you've got your hybrid brace model. I think I heard an excellent talk at AMSEC about their hybrid-based ECMO staff. We ran a little bit of this at Vanderbilt because of some of the things we'll talk about later in the final closing slide. We've gone away from the hybrid staffing model, but you can flex disciplines to accommodate your census, especially acuity census, right? So you more or less what I like to call, you put the right people in the right place to succeed, and for the patient to succeed as well. And so you can run different ratios. You can put people in 1-to-1 scenarios to accommodate the acuity that's needed. It brings in all aspects, so it is the largest available labor pool of all the models because it's combined, right? It's A plus B plus C availability. It can be the least expensive model if you can retain people. We've seen that. You do have the ability to float people back in and out because you have multiple different cohorts of people. If you have low staffing model and you have 1 perfusionist that's on your team, if you have a 1 perfusionist, 2 nursing, 3 respiratory therapy model, and you only have 1 patient on, well, it's easy to float, 5 RNs and respiratory therapists back into the model, and you've really lowered your fixed cost for that particular shift. And once again, I talked about the acuity and the flexibility of the staffing. Cons, ongoing competency. The problem with this is that when you do a hybrid model, you have to lay the groundwork down that where every single cohort of every discipline has to do the same competency, because you can't distinguish between one group and another group because you are a team, and so everybody does that competency. That raises the cost of the program because now you've got all groups, including perfusion, into that competency training, and that you just have to have that. You can't just say, well, perfusion, you do this every day. No, when you're a team, you're a team, and that's the team. That's the right thing to do as far as dynamics. We don't ever want to put anybody above anybody else when it comes to the roles, regardless of their background. Cannot always provide the dual nursing role, but once again, I'm going to put this on the con side, but general staff coverage your specific patient acuity and volumes. I think more so than not, you can't always do it, but at times, and if you have a little more forethought with it, you can do it, depending on what kind of schedule you run and what kind of staffing model you run. Very flexible and efficient patient to FTE ratios. Like I said, it goes right into that's a con. I apologize. That should be on the pro side. That's my mistake. It's very flexible, very efficient. That should be on the left side, right below the last one on the pro. But it can be the most expensive model as well, based on your retention, because once again, your retention plus your competency training is where that's where it's going to get really expensive for you. You have to be able to manage those two. And then, regardless what you do, you have multiple different backgrounds, multiple different work experience, personality, and just knowledge base, right? You have respiratory therapists that know the ventilators. They know the ventilation aspect of ECMO. They have nurses. They know patient care. And then you have perfusionists. They know perfusion and pump. So when you look at it from a standpoint, when you step back, each cohort has a leg up on the other two, regardless of what you're looking at. They have the experience, the knowledge, and the background on a leg up on the other two if you're just looking from a general background standpoint. And it's very it can be very difficult to manage the personalities of bringing three different team members that can have a difference of opinions on the same team. Next slide. And then finally, the overall considerations and tenets of ECMO staffing. Your patient-sensitive values are critical in picking a staffing model. That's, once again, that is your custom. What kind of cake are you baking in your institution? What are your needs? And you have to have your projections. And I kind of lay this on the at the feet of the administrators and the physicians of what are we trying to what you should have a business model, a 1, 3, and 5 year outlook before you start an ECMO program. What are you looking to become? Who do you want to be? What kind of center do you want to be? And what kind of facility are you wanting to hold on to ECMO patients for 24 to 48 to 72 hours? Are you wanting to hold on to them for a week? Do you have the VAD capability, the transplant? Do you have the transplant capability in your facility, or are you going to handpick, during flu season, the people that you're going to do VV? Do you have, do you have what are you going to do, and what can you do? That's kind of the background. The initial training of non-perfusion staffing, it's roughly $20,000 per FTE. It doesn't matter where you're at. Mayo Clinic wrote a paper 2 or 3 years ago that's the cost. It's $20,000 per FTE to get trained. Doesn't matter the background of nursing or RT. It's $20,000 to train them from whatever as a current employee to adjust them to an ECMO specialist. With ongoing competencies, there's between 15 and 25% of loss, meaning that non-productive hours. So if you've got a full-time FTE of 2,000 hours a year, you can count on only that person providing between 1,500 and 1,700 hours of ECMO of their 2,000 hours that you pay them. Those are actual numbers, and we track that. We track that on both sides of at Vanderbilt, on the children's side and the adult side. And once again, going back to the first thing, coverage is 24/7, 365. Even when there's no patient on ECMO, if you're an ECMO facility, what are you? Are you someone that we're going to cannulate emergently? Are you going to do ECPR? Because if you do ECPR, that's a game changer. Because that means you have to have, when you have no one ECMO, you still are paying for someone to be able to provide ECMO services when you have no one in-house, and that is costly. I can tell you it's between if you are going to do ECPR and you're going to have someone in-house 24/7 available, it's between $500,000 and $800,000. That's just the cost of doing that. And if you have one, and that's a fixed cost. That's now if you do, you're going to go ahead and be able to retain and reduce some of that cost because you're going to actually have the patients to offset that. But you're out between $500,000 and $750,000 if you're going to be an ECR program. And then finally, I hear this across the country. Anybody I talk to about it, retention is the single most important variable in ECMO staffing model. It doesn't matter what you do. The retention is your it's your Achilles heel. If you have good retention, you have good results, you have a financially efficient program, and you have a program that has really good outcomes. If you have a revolving door of of people that are taking care of your patients, it's expensive. The results are less than ideal, and you're always putting your thumb in a dike, and you're trying to just hold it together, and that's really the number one model. And so I think when people go to look whether they're going to open an ECMO program, they really need to look hard at what ECMO staffing model they're going to have. And then based on what that staffing model is are you going to be able to retain those people, or are you going to have a revolving door of that same type of person? If you're going to do a perfusion-based model, do you have the retention of your perfusion staff? You're going to do a nursing model. Can you retain your nurses? RT model. Do you have enough RTs? Can you ramp up and ramp down with volume? Or for a hybrid model, a hybrid model is not without its a cost of retention. Because it doesn't matter what cohort you're using. If you can't retain that particular cohort, it's still going to get expensive. So that's what I got, Joe.
Okay. So we'll go ahead and you brought up something which was that really got my attention, and that was how does a private group, and since you're now in our group, good luck. How do you manage when there is the flu season, or ECMO volume goes up, or it goes in Christmas Eve at 3 different hospitals? So yes, there are several aspects to that we have thus far successfully been able to manage. And it's real interesting. I'll tell you this is a true story. I had to do a dog and pony show for a hospital here recently, Kara. And someone was in the meeting as well after the dog, and there were like 3 of us, 3 different groups, not all at the same time, but one after another, that had to do this dog and pony show to talk about your value to the hospital and why they should either retain you as a group or change and go to another group. And one of the people asked this other group, well, what would you do if there was a heart going on, a patient on ECMO in the ICU, and an emergency heart came in and had to go to another room right now? And the response was, well, that's kind of a perfect storm you're talking about there. They were like, but that happens all the time, So, I mean, can you handle that or not? It's either yes or it's no. What are you going to do? Well, we're going to have to tell you that you can't do the case, was the answer. Well, that didn't do well, all right? I've, knock on wood, whatever, in all the time we've been here, it's 10 years now, we have not once yet not been able to cover something that occurred. And I'm really very proud of that. But I will tell you that it gives me anxiety. I don't sleep well at night. I worry constantly. And because this is the reality, this is the paradigm of our environment here in Houston, we are always one person more than we actually need. If you go back and look at all of our numbers, we have peaks and valleys and volume up and volume down, but we basically take the worst possible situation and say we have to have at least one person for all of that and this too. And all of that's a formula based on the number of surgeons that we have, how many do what hospitals we look at, all the previous volumes. Now, our group is salaried. So as an employer, we take the good with the bad. And the employees, because they're happy, I think the team members really versus employees, they're happy. They think they know that we as a group care about each other, and people are always willing to help out and pitch in. We do have to depend on some per diem, and we use them whenever possible. But when we have low census, well, let's first say when we have high census, high acuity, a lot of ECMO, a lot of cases going on, everybody just pitches in and gets the work done. When it drops off, which it always does, especially the dog days of summer, and there's nothing going on, nobody has to take their vacation time, nobody has to be flexed off. You can take your vacation time or day without pay or whatever it is. And that's where I think hospitals go wrong. They want their cake and eat it too. Now, you come from a model that was hospital.
Yes.
So you worked for a private group, then you worked for a hospital, now you work for a private group again. So private groups can manage it, but they have to do either one of two things or a combination of both. You either have to accept a lower profit margin, you have to operate more efficiently by not having a very top-heavy organization with a bunch of managers that do nothing, and the few people doing all of the work, and the revolving door that you see in a lot of these big perfusion groups, and we all know that happens, or a combination of both. And I think that again, not trying to be perhaps a little self-serving or self-promoting, but I think that as a group, we've kind of come up with that. We used to use Tammy as a per diem person and several others. We have good relationships in the city. We try not going in and, for lack of perhaps a more eloquent way to say it, we try not to go peeing in people's cornflakes, so that we have good relationships with other outside facilities, so that we can have that collegial help each other out relationship. If anybody needed it, we don't go there and try to mess up their thing, and in return we have good relationships. They come and help us, we pay well, and we get through our circumstance. So rather than having our call people in the hospital all night and working, we try to use per diem as much as possible, and just try to make the work environment as humane as we can. On the rare occasion when there's just nothing else you can do besides having to do a couple of days of inhumane misery, working your tail off and never getting a break except to, get a little bit of sleep. The people that work with us, genuinely, they do it. They may not do it with a big smile, like, oh, this is great, I get my weekend's completely ruined, but they do it willingly because they know that other people will do it too, will help them, and that there's somewhere along the way it evens itself out. And it's all about relationships, and it's all about caring about people. I mean, it's all about being fair as you can be. And I think that a private group has more of an opportunity to do that than a big institution. Anyway, there's my kind of, threw it all out there and just said it. What do you think?
Well, I think you're right.
Oh, good, you. Anybody?
I think in a hospital setting, they are definitely looking at productive hours, even for a perfusionist, and they're looking often at the numbers. And sometimes the numbers work in your favor, and sometimes they don't. And as you know, people have to take vacation. Sometimes people have emergencies, and hospitals don't always factor into that. They're looking at, I have this many number of hearts or whatever else you're doing, cell savers and things, and I only need this many perfusionists for that. And not always accounting for, you know, the rise of when you're going to have a bad season, or, you know, you get an ECMO and you're not really an ECMO center, so you're not staffed for that. The cases are still being posted in the OR, and you're still having to watch those ECMOs, especially if the hospital is not on board with having relationships with perfusionists outside of their system. You can't get people in to help you because they're not credentialed, or,
that's
you know.
that's a great point, because Matt, it's very expensive for us as a group, but we burden the expense to make sure we pay for the credentialing of all of these per diem people, to, you know, so that it's not their burden, we burden that expense. And hospitals don't want to do that.
No, they don't.
Because you never know when you're actually going to need them, if ever. And they don't want to spend the money to make sure that they can fill that gap. And then you guys we were a relatively small department, and they didn't care that you were up all night, so you were up all night, you were on call, now go do the case.
That's right.
And there's not this concern about them as being people. And that's, you know.
I think the hospital situation can be very difficult to manage if you're not an extremely large program, because then you've got a big team and you can absorb some of that. Or you're a really small program, so you know you're not going to keep that ECMO, or you know that you only have your one surgeon that's doing the cases. If you're kind of a medium-sized program, you can't really have a big staff, but you are going to have those influxes of, you know, doubling your hearts in a month sometimes, and you have an ECMO on top of that.
You can't get a patient off pump. Doesn't even have to be a VV.
Right.
It can just be you can't get this patient off pump, and they're 52 years old, and this was a simple 2-vessel cabbage, and oh hell, we can't let them die, and there's an ECMO,
Right.
which could go for quite a while.
Right. And, you know, do you have any kind of relationships with an ECMO center that's going to take your patient? You know, if you don't have those established, but you are doing some ECMOs, then that's another problem.
And then what if they have a bed?
Right.
What if they don't have a bed for the patient? Now what? Okay, so you know, we'd love to take your patient, but we can't. We're full. In fact, during the H1N1, the people, they were diverting from the med center to us. You remember, you know where? Yeah, I can't say the place.
In the community
that place.
hospitals.
Yes.
Yeah. Yeah. So, I mean, I think the model of staffing, it has to be looked at from all perspectives. And, you know, a hospital model staffing just needs to, they have to have, I mean, I understand you can't staff people, pay them when you don't really need them. But maybe there's some kind of other model that they're going to have to incorporate. You know, having permanent per diem staff that they, you know, guarantee so many hours a year, but then also they can be there to help them have that flexibility when they have those higher caseloads. Matt, do you have something?
So you make a great point. I recently just had we have a relationship with a community hospital that's 4 or 5 hours away from us. We took probably 10 or 15 of their ECMO patients the last 15 years. Or I'm sorry, 10 or 15 of their ECMO patients the last 2 to 3 years. And you know, they're starting to get really, what I want to say, they're really good at patient selection. They're really good at getting the patients on in a timely manner as far as the window of opportunity. And also they say, well, you know, we may want to do this. We may want to go through this route, but they don't want to go all in yet because the nursing and the nursing model and the RT model is a little expensive. What they wanted to do is they wanted to expand on some of their perfusion staffing, and they were going to extend it. And so it's a large perfusion company contract group that's in there, and they've done an a la carte service at, you know, what, an 8-hour what an 8-hour ECMO shift looks like. You have 2 or 3 people, or actually 3 or 4 people in that facility. You talk about a medium-sized program. They're doing between 500 and 600 hearts a year. It's a nice program. You have one patient or one person goes out of town for a national meeting. You have one person go out on a death in the family, and then you get an ECMO patient that week. The next thing you know, you've got someone that needs an emergency surgery on a Saturday. Routine surgery. Well, you don't have anybody available right now. So what you do is send that patient across town to one of your competitors, your hospital. Not, a hospital that is now, instead of you doing 502 cases that year, you're done 501, and the other patient now, or the other hospital that case. And we all know that you want to make sure that you're managing your referral practitioners, right? Your docs. So when you actually are going to try to do something that you're not really sure that you're good at, like you're going to go ahead and take these ECMO patients, you're going to hold on to them for a little while, and then you're starting to turn away business that you know you're good at, that will raise some eyebrows in the administrators' offices. Why did we turn away an emergent cabbage that we know we're good at? Because we're holding on to an ECMO patient because we think we want to get good at that. Mm-hmm. So that will change the dynamics.
Yes.
Absolutely.
Well, Matt, I need you to go down to that place, and I need you to give them my number, because it doesn't matter if the other perfusionist was on vacation or a meeting and the death occurred. Again, we have never not been able to cover it. So we can cover it. So give them my number. Okay?
Yep.
That might get some, don't really do it, but you can do it if you want to. All right, it'd be nice.
I think your joke brings up a fine point about when you are a contract,
Yes.
not seeking out contracts that you can't cover.
Ah, very good.
We know that there are groups out there that do that. They promise to be able to do these things, but they really don't have the staff for it, because they really don't want to staff for that rainy day. They want to staff for what they think is going to happen. Mm-hmm. And I think that's where a lot of institutions get a little bit leery of using contract groups, because they've heard of situations like that.
But at the same time, and that's a very good point you bring up. That's an excellent point. In fact, because what they say is, and I've been doing this a while. I've heard all the stories. I've had the proposals given to me too. Because we're all over the nation, and well, if we need to bring somebody in. What happened to Matt? Where'd he go?
I'm right here.
Oh, there you go. Okay, you came back. Yeah, you went blank for a while. But okay, and we could have somebody here in 12 hours, but they don't have a license in the state. They're not credentialed at the hospital. Oh, we'll just get them emergency privileges. Well, it's just, and I think that the local or the regional perfusion groups are much better equipped at managing these things than these big, large groups. I think these big, large groups have some utility, but I think that's one of their Achilles heels, is that they are stretched way too thin, and they overpromise and underdeliver all of the time, and they're so big they can get away with it. I can tell you this is how I feel. If I have an account, I feel that it is my responsibility to cover whatever comes through that door. That's not their responsibility to say, well, Joe, we're really sorry, we understand, you just don't have the personnel to do it. I've agreed to handle whatever they are capable of doing. Now, if there was a catastrophic event, but even during Hurricane Harvey, we covered all of our hospitals in Hurricane Harvey. Our group did, with no deficiencies. The other groups couldn't do that, and they didn't. And I do, and I am proud of that. I'm maybe being a little bloviating tonight, but I hope you all forgive me for it. But I'm doing it. My show, I can do what I want, right? But no, I think that is a problem, Matt, that and Tammy, that people will promise something, and then when the rubber hits the road, they can't deliver. They talk the talk, don't walk the walk.
I agree.
But I think a hybrid program is a good way to go. I do think that, you know, it may be a little more expensive to train the nurses than perfusionists, but instead of, for example, having a perfusionist sitting at the bedside monitoring the ECMO all night, you have the nurses trained, you have a good relationship with the hospital. The perfusionist could perhaps be in-house, but sleeping and available in case there's an emergency, and if they get called, they can get up and they can go take care of that problem, but they're getting sleep throughout the night and not being up and then having to also function the next day or be out of your system the next day. So that might be a potential hybrid model that might work for some places.
Well, that's a good point too, Joe, as well, because you know, most nurses and RTs, you know, they're either night or they're days. They usually don't flip back and forth too often. But perfusionists, you know, by nature, we're not night or days. We're not weekends or weekday people. We're whenever it comes. And that is one of the hardest things about our job when it comes to involving ECMO, is that we have to have the, you know, the ability to fluctuate between day and night and recover, you know, relatively soon. And it really works. It really, I think that's the hardest aspect of the job when it comes to perfusion.
And then compensating people. You know, that's yet another whole
That's a
talk.
whole other talk.
Kara, you have any thoughts on this? You have staffing issues because you may not have ECMO staffing issues, but you have operating room staffing issues.
Sure.
And you have rooms that need to be covered, and people that may have called in sick or called off for whatever the reason may be. What do you do?
Well, some of us are used to kind of float. So I'm an RN. So even though I moved into the education side, I'm perfectly capable of staffing a room, which I'm happy to do and keep up my own skills. But sometimes the beauty of being a nurse is you can wear so many hats, especially in certain areas. But
And that is an advantage, I think.
Huge advantage.
Much more
I
so
can
than
be an
perfusion.
educator one day. I can be a charge nurse the next day. I can be your CVOR nurse today. I can scrub a few cases if I need to. But you know, you always seem to make it work. But when you throw those human factors in of family emergencies, someone calls in sick at the same time, they don't want a lot of extra staff, FTEs. Productivity is always number one on hospitals' radars, you know, especially in the given day and the payer mix and how things are in the system. And
Yeah.
just, you know, they're
I think a
always
lot of
trying
times
to-
though hospitals are penny wise, pound foolish. Does your staff, and Matt, do you in your perfusion department, but in your previous employment, I'll kind of go around the room. We'll start with Kara. If there are no cases, are people required to take the day off? Do they get told, we're calling you off tomorrow, and if you want to be paid for it, you have to take it as a PTO day?
Sometimes, not all the time. And usually, you know, usually there's people, what they do is the volunteers first. And usually when you're dealing with these amounts of staff, you know, 30, 40 people or whatever, there's usually one or two people that are like, you know what, I'd like the day off. It's not a problem. But when times get a little, you know, thinner and things get that, they do it on a rotating basis, or, you know, they take turns. So they try to rotate through the staff. But, you know, that's a staff satisfaction thing, and it kind of makes people upset when they're using their PTO time
Right.
or vacation
A
time
vacation time.
to make a full paycheck.
Right.
You know, so that's always kind of a sore subject with staff and departments. Or you're still going to be on call. We're going to work you all night, maybe all weekend, but then come Thursday or Friday, if we don't need you, we're going to send you home. You know,
And then you lose your overtime because
that's
it's not
right.
40 hours
and
in
that,
the week.
Right.
that right there.
That would make me very
really
angry.
rubs people the wrong way.
Did they
Yeah.
did they do that with your perfusion department in your previous place?
They tried to do that. We found a workaround. We picked up other things to do. You know, we made sure that we documented what they called non-productive hours, but things that needed to get done, whether we took on helping with training on point-of-care devices, or we're helping with doing restocking of inventory or things like that. We found a way around it so that it kind of just went away, but they did want to do flexing off.
Mm-hmm.
And the nice part about that is then they can usually appropriate to different cost centers.
Right.
So that usually helps even out.
Exactly.
Uh-huh. It's all about playing with the numbers. Matt, what about you in Nashville? Does your department require that?
No, we've come up with a relatively unique compensation model, and so our compensation model is that we're anywhere between 3 and 4 FTE short of what our FTE status is, and that's by design. So we don't run into that scenario, and then we have a salary plus bonus for productive hours,
Okay.
and so we've always and it works well because throughout an entire group of 10, 11 people, you always have a bell curve of people of where they're at in any part of their life, and life changes, right? And so someone that was relatively single with no kids 4 years ago, and we were running this department the same way. 4 years later, they're married and born. We've got someone, potentially that is now an empty nester. Their kids have moved on to college, and so everybody's lives change, and they have different needs at different times. And so the availability of having that flexible of what you want, you can work as much as you want because we are understaffed. We're understaffed, and we do it purposefully, but we always have to staff for what you want to call is that we only allow so many people off at any given time, and knowing that everybody has the capability of working a 6-day every single day that they're not off on vacation. And so you have to have it, like Joe said, the hospital wants it, their cake and eat it too. This has been one of the best scenarios. We are hospital based, but we are run like a private group. And the hospital, it's a win-win for the hospital as well.
Yeah, absolutely. I think that model sounds like it worked great, but you have to be in a program that has a larger team.
Enough people that
cover.
can pick up that want to do that. So on your bell curve, you have to have enough of these people to do that. I'm the exact opposite of you. So it's really interesting for me to hear that. Do you mind if I just ask you a question? And I promise I won't ask too many more questions. But what is the average number of hours a person in your group work?
So we do. So our productivity model has to do with patient care hours, and then there's a call component, and then we call it a 1+. We call it the bubble. Because if you've got 2 people working, that third person, although they don't have to be in the hospital, they would have to be within a 30-minute call range of the hospital because they have to be available, right?
Right.
So there's 3 different ways you actually get compensated. You get credit towards your overall productivity score. So direct patient care hours are a 1-to-1. Your call hours are a very insignificant portion because call hours aren't really productive for the hospital, so they're not real inclined to want to pay for that. But your one-off model, what I want to call the bubble time, our bubble time is the same as whether we have the same as if we're doing patient care, because what we did is we said you can have the call pay. We've given part of that back, saying that we want very little call pay at all. But what we want to do is we always want to have that 1+ model. So when we have 2 things going, we have 3 people collecting at a primary rate. If you can imagine that.
Yes.
And our call pay is really nothing. I mean it's I can give you the example. It's $100 for the entire week per person. I mean,
That's horrible. I wouldn't even tell anybody that. That's horrible.
Well, I mean, but it is. But the
We don't pay
the
anything.
offset.
I mean, I was going to follow up with, we don't get paid for any call.
You don't get paid for any
I'll
call.
take the $100.
Nurses, it's usually like $3
Yeah.
an hour.
Well,
to be on call.
So
but
let me
it-
ask you. Let
It's
me
part
ask
of the
you
model.
this.
It's part of the model. So,
Yeah.
but getting back to your point, how many hours? So we work we have between 40 and 50 hours of patient care interaction per week.
40 to 50 hours of, so not the
And
bubble. We're talking actually in the hospital taking care of the patient.
Correct. We have between 40 and 50 hours now. That's what our all 11 people do on an average. I mean, and of course we've got people that are up in the 60s, and we've got people that are down in the low 30s. But that's the average. And with that model, if that's what works for us.
Okay, good. So what about where you used to be? How many hours per week were you first of all, were you required to be there 40 hours?
No.
No. Okay, that's good.
We were required to cover the cases and make sure someone was available, between the set hours of normal operating hours, whether that's 7 to 3 or 7 to 5, kind of just depends on which administrator was in charge at the time. But we were able to, stagger staffing in if there aren't cases, or, early leaves when they're, things finish up early. But being a small team, we only had, one person on call. And as you know, that works when there's only one emergency or there's nothing running late. So we always had to have the kind of understanding that if more things happen and you were not coming in yet or you've already gone, you're going to have to come back. And being a small team, it kind of worked simply because you knew the other person was going to have to do it for you at some point. So
Right, absolutely. And then in nursing, you're required to be there. There's no such thing as, you're working, but you're not physically in the hospital. Or is there?
You mean for call?
For anything.
Well, I
Like
mean,
if
your
you're-
shift.
So you have to
a
clock
shift.
in.
You have a
Right,
shift.
yeah, most nurses are not salary. If you are, you're in a management or administrative type of role. So you're there working, so obviously anything above and beyond. And then also call pay is very minimal, but you get paid to be on call. It ranges anywhere from $2.50 an hour to maybe $3.50 an hour,
$3.50
depending
an
on
hour,
where
yeah.
you're at. And in extreme cases, sometimes they'll even ask nurses to change their shifts, flex kind of when they're coming in to meet the demands of the unit at the time, or as things change. And there's always opportunities to pick up extra shifts or cover, or
Right.
ask for volunteers to come in.
Right.
And there's always people that want the extra hours, so it usually works itself out as well.
Right. Well, Matt, okay, I'm being told by the technical staff that our time has come to an end. Matt, once again, I want to thank you so much for just a great series. No, seriously, really great series of talks. You are very, very knowledgeable on the subject of both ECMO and certainly perfusion department economics, if not also just hospital economics.
Yeah.
You've really given me at least, a lot of things to think about, and I think the same applies for our panel and those watching us out in the web world and who will watch this at some later date. So we want to thank you so much for that, and I also want to thank Tammy. I want to thank Kara,
Thank
both
you.
for being here, and Caston, her son, who's running around out there somewhere, probably eating, and we're all starving too. Hopefully you are too, Matt. You can get home. But thank you for just your generous time. We can't, this kind of thing is so important, and it brings such a great value to our profession for us to have this out there in the web, and also for our colleagues to see, and for even others to see, to know that what we're all about and what we're actually doing. I asked one time, I had a little table and I had a little jar, and I said that I would give somebody, you would get $1 if you could tell me what a perfusionist was. So people would come up and it would just say, win $1. And people would walk up and I would say, what's a perfusionist? And I tell you what, I made perfume. You played music, no one ever, the only person that ever got it was I was standing in the hallway at Memorial Hermann TMC. I got thrown out of the hospital too for this. I don't know why they got upset, but I had a camera set up and doing the same thing. These are people in lab coats that didn't know what a perfusionist was, but one veterinarian happened to know, so he won the $1. And then the security came and said, "Who the hell are you? And you need to get your stuff and get out of here." So I got tossed out. All right. Thanks again very much. We'll see you all tomorrow morning. Matt, you won't be with us again. You're always welcome to join if you'd like, though. You can always check in with us. And I'll be calling you again pretty soon to talk about some of the other stuff that we're doing with the Tennessee Perfusion Society. You're the past president, right? And you've got your big meeting coming up. And we need to start advertising that. You know, we've been talking about that for a while. We need to get that done. And
October 5th.
Huh?
It's October 5th.
October 5th. So you need to call. We need to get that online and get that going. Have a safe trip home, everybody, and we'll see everybody that's going to be watching the program tomorrow morning back here at 9 something or other. So check online on perfweb.us and you'll find out about it. Good night, everybody. Good night, Matt.
Good night.
Night.
Tammy, Kara.
Thanks,
Night.
Joe.
Bye,
Thanks,
everyone.
Matt.
Thank you.
Thanks,
Bye.
Joe.
Mixed cannulae, expanding performance standards. High-performance cannulae for direct and femoral cannulation in minimally invasive cardiac surgery. LivaNova's complete range of mixed dedicated products allow easy and reproducible procedures. The portfolio includes the sutureless aortic valve Perceval, Memo 4D for mitral valve repair, the HeartLink system for assisting the perfusionist in applying goal-directed perfusion therapy, and a broad choice of high-performance dedicated cannulae. LivaNova's range of cannulae suit every cannulation technique for minimally invasive cardiac surgery. Venous and arterial femoral cannulation can be performed using the WRAP Venous Cannula and the EZ-Flow Duo. For arterial, direct, and venous femoral cannulation, the EZ-Flow aortic cannula and the WRAP are available. For venous femoral access, the LivaNova WRAP cannula features a dual-stage configuration for optimal drainage of the inferior and superior vena cava without interfering with the right atrium. The high-flow dynamics of WRAP improves the capability of drainage with a low pressure drop. An optional Sellinger dilator kit is available to perform percutaneous insertion. The LivaNova EZ-Flow Duo Cannula is designed for a safe and smooth femoral arterial cannulation. Its conical dispersion tip design allows a more gentle flow in the femoral artery, and its red cap avoids blood backflow during obturator removal. A dilator kit for percutaneous insertion is also included with the cannula. EZ-Flow cannulae are designed for safe, reproducible, direct aortic cannulation and include a malleable stylet to aid cannulation insertion, facilitating bloodless introduction into the aortic arch, as well as a special conical dispersion tip for a more gentle flow in the vessel to reduce shear stress.